Let's have a look at exercise 10b, page 466. 1. At the end of 2016, again, at the end, the population of a city was 200,000. At the end of 2018, end of, the population was 264,500. A. Assuming that these end-of-year figures follow a geometric sequence, find the population at the end of 2017. Okay, so let's write this down, what we have. We've got the end of 2016. So we know 2016 at the end of the year is 200,000. The answer is also asking the end of the year. So we can say 2016, 200,000 is U1. 2017 we don't know, but we know 2018 was 264,500. Well, we can find R, okay, using this, because R is X over 200,000, remember? U2 over U1. That should equal, it says assuming these figures follow a geometric. So we know it's a geometric sequence, so we can do this. X on 200,000 should equal 264,500 on X. Remember, U2 over U1 equals U3 over U2. Cross multiply, we've got X squared equals 200,000 times 264,500. And so therefore X equals 230,000. Okay, couldn't be minus, just the positive one, right? 230,000. And that's the correct answer there. B, calculate the population at the end of 2020. Wow, that's already history there. So U1, we were told, is 200,000. We can work out R now because we know what X is, and we've got 200 there. So we know that X was 230,000. So R is 230,000 over 200, which is 1.15. It also should be 264,500 divided by X, divided by 230,000. So that also equals 1.15. So if we know R and we know U1, the population at the end of 2020, let's just remember, if you can put a pen to paper, it does help here. So we know that's U1, 2017 is 2, 2018 is 3, 2019 is 4, 2020 is 5. So U5 is 200,000, that's U1, times the R, which is 1.15, to the power of 5 minus 1 is 4. So it's 349,801. And so I've written it in English there. It's always a good idea to write it like that. Okay, try to write it in a sentence when they ask there, calculate the population at the end of 2020, at the end of 2020, 349,801. C, comment on whether this increase will continue, give a reason for your answer. Okay, it's difficult to give an accurate answer as there are many factors to consider, including the economy. Yeah, there's many factors. Again, when we're dealing with living things, it's a bit hard to predict that far in the head. The population at the end of See, it says whether it was continue, what, forever? Maybe not, huh? Maybe not. So that's what the book says. I mean, that's basically give an answer that looks something like that, and you should do okay with that. Number 2, 1 kilogram of tomatoes cost $2.20. At the end of 2015, right, it was $2.20. Prices rise at 2.65% per year. That means this number's going to go up, right? It's $2.20 at the end of 2015. So at the end of 2016, it's going to be a larger number than that, right? As they rise. Find the cost of a kilogram of tomatoes at the end of 2019. Well, that's just 1 kilogram. 1 kilogram, same units. A good idea to check the units at the end of 2019. So let's write down what we know. We know that 2015, that was 220. So we got that one. We know at the end of 2019, we don't know that, but I've given that a value of X. Okay, we call that X. Okay, so we know U1 is 220. We know that U5, 2019, right, is 1, 2016, 17, 18, 19. We'll just call that X. We're looking for that. Find the cost. So we're looking for that in 2019. Well, they tell us that the price rise is 2.65%. So we know that R is going to be 1 plus 0.0265. So that's R. If you're not sure how to get that, remember, it can't be just 0.0265 because it wouldn't go up. It's increasing, it says. So it's the initial price, and it goes up 0.65% a year, so that means it's increasing at 1.0265. That's R. Now, so U5, we already established that's U5, is equal to U1 times R to the power of 5 minus 1 is 4, and that is 2.44263. Therefore, at the end of 2019, the cost will be $2.44. Remember, in IB tests, 2 decimal places, unless they ask you to round it up to the nearest dollar, make sure you put the cents in there, 2 decimal places. 3. Petra buys a camper van for €45,000. Each year, the camper van decreases in value by 5%. Okay, so we're going to expect that number's going to drop over the years, right? It depreciates, it decreases. Find the value of the camper van at the end of 6 years. So the first thing is think about what's happening. We're looking for a number that's going to be less than that. So what do we know? Each year, the camper van decreases in value by 5. So she buys it for €45,000. Find the value of the camper van at the end. Again, we've got at the end of. So we've really got to do the end of the first year. So that's why I'm calling 45,000 U0. Because U1 is at the end of the first year. She buys it in 1 year. And by the end of that first year, it's going to be 45,000 times 0.95 because it's decreasing by 5%. So that's 1 minus 0.05 is 0.95. So I'm going to call that U1. Okay, find the end of at the end of 6 years. So therefore U6 is equal to this. See, I'm not using 45,000. I'm using this because it's the end of the first year times 0.95. Okay, that's the R, common ratio. And 6 minus 1 is 5, and I get 079.135. Therefore, at the end of 6 years, the value will be €33,079.14, or 0.14. Good, so that's good. Let's have a look at 4. Bo spends €15,000 buying computer materials for his office. Each year the material depreciates by 12%. So again, if that's going to be one of our first terms, then the number's going to get smaller and smaller and smaller because it depreciates. So keep that in mind. We're looking for numbers. The final numbers are going to be smaller than that, aren't they? So 12%. Find the value of the material after 3 years. Okay. Each year the material. So at the end of the first year, it's not going to be 15,000. So I've kind of done the same here. I've got U0 is 15,000, but U1 is 15,000 times 0.88. Because the question, find the value after 3 years. So it must be the end of 3 years. So I'm going to say U1 is 15,000 times 0.88. That 0.88 comes from 1 minus 0.12. And that's 0.88. Okay, so we work out that my U1 is 13,200. Now we've got the formula, haven't we? So it says after 3 years, so U3 equals U1, and that's 13,200. I didn't use 15,000, right? I didn't use that because that's at the beginning of the first year, or sometime during the year. It depreciates by that much in the first year, at the end of the first year. So I've got 0.88. 3 minus 1 is 2. That's that number, which is €10,222.08. Okay, there, and I think that's the correct answer, though I didn't mark it as correct. I think it's okay. Now B, find how many years it takes for the materials to be worth 5,000. Well, that means that whatever term, if something is worth 5,000, we've got to find out how many years. Like just for example, in the first year, we said it was 15,000 times 0.88. In the third year, we said it was going to be 10,222.08, and this number is getting smaller and smaller. So we want to know when that number gets to 5,000. Okay, so we put that on the left here. 5,000 equals U1 is 13,200 times 0.88 to the power of n minus 1. Okay, so we've got that. Now this is from the formula, which is the nth term equals U1 times R to the n minus 1. Now, so I'm going to just move that 13,200 to the other side. I've got 5,000 divided by 13,200, and that equals 0.88 to the n minus 1. Now, I'm not sure if you've used logs in this way, but I'm going to do logs. Okay, I've got log 50 on 132. If you allow me there, I've knocked off the 2 zeros. I've got 50 on 132 equals. Now, remember, when you take a log of 0.88 to the power of n minus 1, you bring the power down to the front, so that's n minus 1 log 0.88. And then I'm going to move this term here under here. Okay, I'm going to move that under there. Okay, and then I'm going to add 1. So you see what I've got here? I hope you can see the 2 steps. I'm just looking over it myself, what I did. Now what I did here was, in my mind, I just multiplied that out already. I've got n log 0.88, and I've got minus 1 log 0.88. So if I just move that down to here, I would, if I just done that, I would have had this over that equals n minus 1. Well, if I take the 1 to the other side, this effectively is 1. So I've just added 1. Okay, that's the same as this over that plus 1. Okay, well, I've kept it together. Now, if you've got a log of 2 numbers like this, it's actually the numbers multiplied together. Okay. So it's the log of 5132 over 132 plus the log of 0.88. Okay, well, that means it's the log of those 2 numbers divided by the log of 0.88. That equals n. And when you resolve this on your calculator, you get n is equal to 8.5941. And therefore that's 8.59 years. Okay, normally n is a whole number, but this is giving us as part of the year here. Okay, so it's 0.6 of a year. Okay. Now there's an alternate way to do this, which is a little bit easier probably. So I've done that in green here. Or, when in this step here, what I've done is, where I've got 0.88 to the n minus 1, that's effectively the same as 0.88 to the n divided by 0.88. I've just moved it down. That there is this term, because it's 0.88 to the n divided by 0.88. Okay. I moved the 13200 over to here, so I've got 5,000 over 13,200 equals 0.88 to the n over 0.88. So I've got 0.88n equals 0.88 times, again, I've chopped the 2 zeros off, 50 over 132. And then remember the relationship between this, when you do something with an exponent here, that this can be rewritten in logs as the log of 0.88 of that number equals this number. Hopefully you've done that. It is actually in the textbook, and we'll go through it again. If you haven't, let me know if you haven't. But that they are equivalent. They are equivalent. Okay. Okay. Well, I'll come back to that in a minute. Okay. We got n equals 8.5941, which is the same. N is 8.59. Okay. Let me just go through that in a bit more detail, just to show you that this line here and that line is the same. Okay. Let's have a look. Okay, so I've written this up here, and so this is basically, these are equivalent. If you've got log to the base a of b equals x, then this a to the power of x equals b. Okay, you can try that in a calculator by substituting different numbers in, but that's true. Okay, so if you've got log to the base a of a number that equals x, then you can say that a, that base, to the power of that, the right-hand side, a to the power of x, equals b. Okay, and that's what I used here between that step and that step.